Okay, so let's start it. So here you got some RPM. You got some RPM of the driving pulley. Okay. Then here it is the intermediate pulleys mounted on intermediate shaft N2. So definitely as diameter diameter of the driven pulley is less as compared to the that of the driving pulley, the RPM speed of it will be more. Okay, we are neglecting the sleep present between them. Then you know that pulley 2 and pulley 3 both are mounted on same shaft. So RPM of third pulley, RPM of the third pulley will be same as the RPM of the second pulley because both are mounted on same shaft. Okay. Again, you can see the diameter diameter of third pulley is more as compared to the diameter of fourth pulley. Okay. So you will have the RPM of the fourth pulley, RPM of the fourth pulley greater than N3. करेक्ट. इसका डायमीटर कम होगा, ऑटोमेटिकली आरपीएम जो है इसका ज़्यादा होगा. सो यू कैन सी यहाँ पे आपको कितना रिडक्शन मिला, N2 अपॉन N1, और यहाँ पे रिडक्शन कितना है, N3 अपॉन N4 अपॉन N3. Okay, so definitely there this ratio, this velocity ratio will be very high. You have achieved a high amount of speed reduction. Like here RPM has increased, okay, by a very high amount, which you might not achieve using a single shaft, using only two shaft. Okay, so that is possible with the help of compound belt drive. Getting it? So these two purpose are there. One is that when the distance is very large between main driving shaft and main driven shaft. Second, to achieve very high velocity ratio. Next is your stepped or cone pulley drive. So this drive you will find in your machine tools. Okay, where you work, where you do the production process at different cutting speeds. Okay, for example here the pulleys is stepped pulley like this. The pulley is in this form. So ये उसका first step, ये second और ये third, like this. So what is happening? First, initially belt is running between these two combination. This pulley has a combination with this one. Okay. Then your say it is the main or driving shaft. So RPM will be N1, and this RPM is generally constant. This RPM is generally constant. Okay. And here RPM of the driven shaft, RPM of the driven shaft will depend whether the belt is on the first step, second step, or third step. If suppose you will slide this belt, if you will slide this belt and will make the belt over these two second combination, this one and here. So obviously here diameter of the pulley is increasing. As diameter of the pulley is increasing, this RPM will reduce. RPM of the driven shaft will reduce. Similarly, if you want to reduce it further, you take the belt to the third step of the cone pulley. In this way, you can obtain different velocity ratios. Though only one shaft is there, one driving shaft is there, here only one driven shaft is there. But how many velocity ratios you are getting? Almost you are getting three combinations, three velocity ratios. So that is possible using the stepped or cone pulley drive. Next is fast and loose pulley drive. Okay. So say it is the line shaft, that is your driving shaft, driving pulley. Okay, you can see driving pulley used is wide, very wide. Okay, and here it is the driven shaft, machine shaft. Some machine is attached here. So shaft is uh, this shaft is providing power to that application. Now on this driving shaft, on machine shaft, two pulleys are mounted. One is called as loose pulley and one is called as fast pulley. Fast mean it is fastened with the shaft. Okay, you have connected this pulley to the shaft. Means when shaft will rotate, when driving shaft will rotate, this pulley will also rotate because it is mechanically connected with the machine shaft. Okay, but this pulley is the loose pulley, which is not mechanically connected to the shaft. What does it mean? It means that loose pulley will only rotate, and when it will rotate, the shaft will not rotate as there is no such connection between them. Okay, so suppose if you want to stop the machine, what you will do? You will slide the belt over the loose pulley. Okay, so automatically when the power is given to the loose pulley will rotate only. Okay, but shaft will not rotate. Your machine will be at halt. Machine will not. Machine is not getting any power. Suppose if you want to start the machine, if you want to transmit the power to the machine, you have to slide back this belt over the fast pulley, which is actually connected with the shaft. So when this belt is transmitting power to the fast pulley, pulley will rotate as well as the machine shaft will also rotate. Okay, so it is kind of like clutch. अगर आप टू व्हीलर यूज करते हो, if you use the clutch, if you press the clutch, power is not transmitted from engine to the rear wheel. So आपका बाइक वहीं पे रहता है, it doesn't move. But if you engage the clutch with engine, means now there is connection. So your automobile starts running. Okay, so it is kind of clutch arrangement. So when it is desired, when you want to stop and start machine without touching the main supply, without stopping the main supply. Same happens in case of automobiles. Even if you do not um, switch off the engine, if you do not kill the engine, okay, still the bike is able to be at rest position even if the engine is running. Okay, so that is the concept of fast and loose pulley drive. Okay, then next is your this concept, the velocity ratio of a belt drive. So how it is defined? We have already defined it. So how velocity ratio is defined? The speed of driven pulley to the speed of driving pulley. That is this ratio N2 upon N1. Suppose if your driving pulley is say number 5 or number 6, so your velocity ratio will be N6 upon N1. Okay, is equal to, that speed is inversely proportional. Speed is inversely proportional to diameter of pulley. If diameter is large, diameter is high, then definitely that pulley will rotate slowly. And if diameter is more, the pulley will rotate with high speed. So velocity ratio can be written as N2 upon N1 is equal to D1 upon D2. Okay. Uh, And if when you consider, so in some problem thickness of belt is also given. So if thickness of belt is given, so velocity ratio formula can be modified as n2 upon n1 is equal to d1 plus t upon d2 plus t. Okay, here this formula can be written as in terms of diameter, in terms of radii, r1 upon r2, r1 upon r2. So when you take the r1 and r2, actually you measure the velocity here at the surface of the pulley. यहाँ पे आप velocity measure करते हो, that is say v1, v1, and you know that v1 is nothing but r1, r1 into omega 1. R1 is the radius of the driving pulley. Omega 1 is 2 pi n1 upon 60. Okay, but in case when you consider the thickness, when you consider the thickness of the belt, then you measure the velocity at the mid of the belt. यहाँ पे measure करते हो velocity. तो अगर आप in the middle section of, at the middle thickness of the belt, if you will measure the velocity, definitely radius will be greater here. Though omega 1 is same, but radius will be now, radius will be r1 plus whatever is the thickness of the belt t upon 2. It is your radius multiplied by angular velocity. So when you consider the thickness of the belt, the velocity ratio formula is this: n2 is upon n1 is equal to d1 plus t upon d2 plus t. Okay, so you note it down, this formula of velocity ratio, you note it down. And let me know if you have drawn the diagram and taken the formula. So I think this diagram you should also draw at least one time. More you, more number of times you draw it, more it gets clearer in your mind.
Done, sir.
Okay. Next, so it is the velocity ratio of a belt drive when the power transmission is directly from driver to driven. Okay. Now let us see the velocity ratio of a compound belt drive. Okay. So in case of compound belt drive, this formula gets modified. Now velocity ratio is the what is the final, what is the speed of the final driven gear. So final driven gear is here. You are transmitting power from 1 to 4. So how you will write the velocity ratio? Velocity ratio of this drive. This drive is equal to n4 upon n1. And if you do the calculations, then you will find that it is equal to d1 into d3. That is the product of diameters of driving pulleys. Okay. So it is driver, it is driven. Okay. It is driven, and to this the third pulley is driver. Getting it? So there are two driver pulleys and two driven pulleys. So how you will write down the formula is equal to the product of diameter of the driving pulleys to the product of the diameter of driven pulley. You can easily prove it. See, n4 n4 upon n1. Okay, it can be written as n4 upon n3 into into here the n n4 upon n3 into n2 upon n1, राइट। देखो ये n4 और n1 तो है यहाँ पे, जो n2 इज इक्वल टू n3, जो जो पुली 2 और 3 है वो सेम शाफ्ट पे है, तो n2 इज इक्वल टू n3, ये कट हो जाएगा। ओके, so n4 upon n3, you can write it like in terms of diameter, you can write it d3 upon d4, inversely proportional to diameter, d3 upon d4 multiplied by n2 upon n1, so it can be written as d1 upon d2. So this formula comes. Similarly, if there are 6 pulleys in a compound belt drive, there is one more intermediate shaft. Okay, then you can write the velocity ratio for the drive as n6 upon n1 equal to d1 into d3 into d5. The product of diameters of the driving pulleys to the product of diameter of the driven pulleys, in this way. Okay, so you note down this too. So we will stop here. You can note it down. Any doubt you have regarding IA or something, I already told that in IA2 you will have 3 modules. Module 2, special mechanisms. Module 4, cam and follower. And you know this module, module 5. So you expect whatever is covered till last lecture, that will be in your syllabus in for IA2. You note it down.
So
Any
when is IA2?
IA2 is starting from 12th of May. आपका 12 मई से वो स्टार्ट हो रहा है। ओके,
Done, sir.
okay. So you start doing study. I know that you are already doing it. I have also enabled a link for submission of your assignments. I hope that you are also submitting that. It's tough time.
Yes, sir.
Okay. So any other question from anyone? Okay, so
So when will be practical and Viva?
प्रैक्टिकल एंड वाइवा आई थिंक माधवी मैम का कंफर्म हुआ है ना, माधवी मैम का कंफर्म हुआ है आई का। आप माधवी मैम ने बताया है आपको?
नहीं सर, किसने नहीं बताया।
मुझे सिर्फ माधवी मैम का आया है, उन्होंने फिक्स किया है। मैं बताता हूँ आपको, माधवी मैम का जो है 22 मई को होगा ओरल एग्ज़ाम आई का। और आपका शायद दूसरा जो प्रैक्टिकल है वो पाइथन प्रोग्रामिंग का है ना? या कौन सा है आपका? 3D प्रिंटिंग कौन सा है? दैट प्रैक्टिकल इन योर सिलेबस देखो, ये तो कॉम का सिलेबस।
CNC and Python प्रोग्राम दोनों का है।
हाँ, तो वो उसका एक प्रैक्टिकल है शायद, तो वो श्री प्रसाद सर व्हेन एवर ही विल इन्फॉर्म, सो आई विल इन्फॉर्म।
सर आई का टाइम टेबल कब मिलेगा?
आई का टाइम टेबल अब अभी आज के 5th है, फ्राइडे तक आ जाना चाहिए, फ्राइडे
Yes,
या मंडे। हाँ ठीक है।
Sir, I is from next Wednesday, correct?
यस यस,
Up to
up to just a second, I will show you. So IA will be on 12th, 15th, 17th, 18th and 19th। दो दो तीन तीन दिन का नहीं, सिर्फ इसी में है। 12 का एक है और 15 पे एक है, मतलब इसमें ही आपको 2 दिन मिलेगा। फिर 15 के बाद 17 को है, उसमें 1 दिन मिलेगा, और फिर 17, 18, 19 कंटिन्यू है।
so what about Vivas?
वाइवास कॉम का वाइवा तो नहीं है, इसका आई का है और एक पाइथन प्रोग्रामिंग का है। एफएम का नहीं है, प्रैक्टिकल नहीं है, वाइवा नहीं है। आप सिलेबस चेक करो कौन कौन सा वाइवा है, 2 ही है। आप जहाँ तक मुझे पता है। कहाँ गया सिलेबस, मैं बताता हूँ आपको। जस्ट अ सेकेंड। मैथ 4, देखो प्रैक्टिकल आपका है, आई का प्रैक्टिकल है, प्रैक्टिकल या ओरल जो भी है। पाइथन प्रोग्रामिंग का है 25 मार्क्स को, आई का 25 मार्क्स को है। सीएनसी एंड 3D प्रिंटिंग का 25 मार्क्स को है। एक मिनी प्रोजेक्ट है 25 मार्क्स का, मतलब 3 सब्जेक्ट का है आपको, और एक मिनी प्रोजेक्ट है वो जो आप करते हो, जो भी आपके टीचर्स हैं। तो ऐसे 4 सब्जेक्ट का प्रैक्टिकल और ओरल होगा। एनी अदर थिंग?
no, sir.
Okay, so let's stop here. You can post queries on my personal number if you have any. Okay. Again, whom I wanted to talk with, Saurabh Mishra is there. Saurabh,
So I'm here.
Saurabh, you call me after the session, okay?
Okay, sir.
Okay. So let's stop here.
Thank you, sir.
Thank you, sir.
Welcome.